Hello, welcome to part 2 in a series of videos on the Saros Cycle. And what we're looking at now, and by the way, you don't need to watch part 1 if you're just jumping in here to part 2. Each part of the series will stand by itself as well. What we're looking at now is that each consecutive eclipse in the Saros Cycle is very similar. It's a series of eclipses every 18 years, 11 days, and 8 hours that are very, very similar in many ways. And one of the ways in which they're similar is that these succeeding eclipses that occur every 18 years, 11 days, and 8 hours, they occur in a similar latitude on the Earth. In fact, what they do is they will move very gradually, either from the North Pole down to the South Pole or vice versa. They will start at the South Pole and move their way up to the North Pole. And what I've shown here, this is from the Sirius astrology software, you can look at the solar eclipse paths, because as you no doubt know, a solar eclipse, when it occurs, is only visible in certain places in the United States. And what in the United States, in the world, they're only visible in certain places in the world. And what we see here is the central line, where it's, the center of that area. It actually covers a fairly large area where you can see it. But in this red curved line, it shows where it's, the center of the path is where it's most visible. So, for example, what I did here is I put 4 consecutive eclipses in the Saros cycle. So, number 1, I put a little pink border around these so you could follow them. So, the first one, the end of it is over here in Northwest Africa. This is on April 28th, 1949. This is just an arbitrary solar eclipse. Happens to be the one before I was born. So I'm just picking any old solar eclipse. This happens to be a partial solar eclipse, nothing special about it. It starts over here in North Africa, and it goes up, swinging up over Canada, and then ends over here. So I put this pink around it so that you can follow it. And roughly in the middle, approximately in the middle where I put the number 1, somewhere up in here is where the eclipse reaches its maximum, the most perfect that it is. So if you wanted to see this eclipse as best as it can be seen, you would want to get up here in this area. And we saw that in the Sirius software, it'll show you the eclipse chart. And I showed in the first video in the series how you can select to show it at the maximum latitude and longitude. And for this particular eclipse, let's see, if I go back to the Sirius software, here's the eclipse chart. I want not this one. This is the first one in the series, which October 12th, 1624 is the first one in Saros Cycle 147. And if I go to April 28th, 1949, still Saros Cycle 147, 19th one. So this is the 19th one. This had to be 3 days before I was born. And I selected the maximum eclipse, 62 north, 56 west, if we round it off. 62 north, 56 west. Well, 62 north, 56 west would be somewhere up in this range, right up here where the 1 or the 4 is, about in the middle of this path. So that's the eclipse on April 28th, 1949. Now I go 18 years. That would bring us to 1967. 11 days later, that would be about May 8th or so, 1967, and that's the blue one. So the next one in the Saros cycle begins here on the west coast of Mexico, comes up, and then continues over here. And what happens is they move about 120 degrees to the west. So we have this one, number 1, then we have number 2, and then we go another 120 degrees, about 1/3 of the world that to the west. That's because of the 8 hours. That they have these Saros Cycle eclipses happen every 18 years, 11 days, and 8 hours. So about 120 degrees. The next one occurs. This one is on the previous one, May 9th, 1967. I add 18 years. I get 1985, May 19th, 1985, and that's the green one. So you see where it is. And it's going to reach its maximum, up in this area. What is that, like north of Latvia and Lithuania, wherever that is, way up here. And then just to show a complete cycle, the fourth one is going to come back to a similar place as the first one, this yellow one. So the yellow one and the pink one is the full cycle of coming back 18 times 3 years from 1949, and then coming to this last one in 2003. It's come back, it's a little bit, it hasn't quite reached the exact same place, a little bit earlier. So it's got its maximum visibility over here closer to Greenland. It's moved a little further east. It's come almost back to the beginning. So consecutive eclipses in a Saros cycle, they occur in a similar place, and we're told that they start at the North Pole, move down to the South Pole, and vice versa. So to check that, I wanted to see if all these things we read about are really true, and exactly how true are they. So what I did this is just the same thing I just talked about. Here it is. What I did, took a lot of time actually to do this, but I was very, very curious. I took the time to do it, is I have each one of these eclipse charts, and I just typed in a file, like a notepad or something. I just typed in number 1 in this particular series. I just picked one series, and I wrote down 72 north. And then I went to the next one, and I said, okay, number 2, 71 north. Number 3, I just went through them. Now I'm up to the third one, number 3 in this Saros Cycle 147, and it's at 70 north. I just wrote them all down and organized it. And after a long time of tedious work, because I was very curious, here's the result. Here's the result. So is it true that a Saros cycle starts near the North Pole? This is the first one in Saros Cycle 147, which was on October 12th, 1624. And I just showed you 72 north. I just showed you the next one was 71 north, and the next one's 70 north. I just rounded it off to the nearest degree. And it is true that it started near the North Pole, not up near 90, it would have to be 72. So that's interesting when they say near the North Pole, how close is near? Well, in this case, 72 north. It's not up like right near the North Pole. 72 north, and it does come down, and it does cross the equator. I put in blue here, 5 north to 2 south. I'll explain what this red is in a second. But the overall thing is it starts at 72 north, goes down, and then it goes further and further south, and then does end up near the South Pole at about 72 south. So it is true, but it is not a simple, steady movement. In red, I show where it's like going in the wrong direction. Instead of heading to the equator, it hits 61 north and kind of stops there and goes up a little bit to 66 north, goes all the way up to 81 north. So it's not a simple movement. This is from the point of maximum visibility. If you use the point of maximum visibility, that point of maximum visibility is not a simple movement from the North Pole to the South Pole. It's similar to like the motion of planets where like they go retrograde. It's like instead of heading towards the South Pole, it like retrogrades back. Well, that's the wrong term, but just an analogy. But it goes back, way back. So Overall, it does. Now, does this mean anything astrologically? I don't know. But before we can interpret something, it's good just to know the astronomy of it. What the heck is happening? So this is just interesting information about the Saros cycle. Again, that it's true that the Saros cycle starts at a pole, goes down to the other pole, but it is not a simple, steady movement. So it goes down to 61 north, it goes all the way back up to 80. Look at this sudden jump. Also, we notice that it's not nice and steady. Like from this eclipse, which is the 22nd eclipse in this cycle, it all of a sudden jumps up from 66 to 81 and then gradually comes down. And there are some big jumps along the way. So, for example, where's a big jump? I don't know, like this one, 21 north to 13 north to 5 north. You know, we've jumped from 21 north to 2 south within 3 eclipses. It's like moved very rapidly. Whereas other places like here, 68, 67, 66, 65, 64, 60, very gradual and slow. So this movement from the North Pole to the South Pole, it sometimes kind of goes very, very slowly, degree by degree. Then it all of a sudden starts jumping like over 10 degrees between eclipses. Anyway, it starts at one pole, in this case the North Pole, goes down to the South Pole at an uneven rate and not completely, in one direction. So it's interesting. It is interesting. Look at this, where it goes from 38 south. Instead of the south getting bigger and bigger and bigger, it actually starts heading back to the equator, gets up to 6 south before it starts heading back down to the South Pole again. So all of this red is in like a reverse direction from the overall pattern. And that's a big reverse direction. It's gone from 30 south up to 6 south, heading back to the equator, and then it starts continuing back to the South Pole. This particular Saros Cycle 147 has 77 eclipses. The typical is 72, has more than average. And when it gets to the end, it kind of hangs out around the Arctic Circle, around 6, which is its, 66, 67 south. It kind of hangs out around there in that rough area. Okay, we're just noticing what is really happening. Is what we read in the books true, and exactly how does it work? That's what actually happens. Just kind of nice to know. Now, here's another thing that I became interested in. Alexander M. Zaragich, who I mentioned in the first video in the series, he brought this up to me, and it got me very, very curious. If you take the point on the Earth where the maximum eclipse occurs, the first eclipses we would assume occur near the horizon, and then as we get to the middle of the Saros cycle, they would come overhead. Is that true? Are the first eclipses, we know they occur near the North Pole very roughly, but are they also near the horizon? When you look at them, the answer is yes, and it's a clearer, more straightforward pattern, not a perfect pattern. That, actually, it's a nearly perfect pattern, yes. I mean, the planets, the maximum eclipse point, let me show you what I'm talking about. In this eclipse map, say this eclipse on May 19th, 1985. If you travel to this area up here in northeast Scandinavia, wherever that is, right up here, at this point of maximum eclipse, or maybe it's a little bit over here, wherever it is, we can look at the chart wheel and we can see, let's look at where it is, May 19th, 1985. Let's look at the solar eclipse for May 19th, 1985. the maximum eclipse occurs at 63 north, 12 minutes, 55 seconds, 80 east, 53 minutes, 29 seconds. Let's round that off to 63 north, 81 east. 63 north, 81 east. That's somewhere in this area, right in here, exactly what it's showing. So somewhere, where that exact latitude and longitude is where this eclipse is most visible. And if this eclipse is near the beginning or ending of the Saros cycle, you will see it near the horizon. So if you travel to that place, and it's one of the first eclipses in the cycle, then it'll be near the horizon. Now this particular eclipse, it tells us right here, it's number 21 out of 72. It's not near the very beginning. Actually it's a little more than 72, but somewhere around the 30. It's getting kind of close to the middle. So it's, it's probably not right near the horizon. It's probably up, reasonably up in the sky. Now let's look at it more closely. This is the altitude. So if we look at cycle 147, I just took one cycle as a test case. The very first eclipse back in 1624 was the first eclipse in this cycle. It happened right on the horizon when you view it from where this eclipse is maximum. And the sixth one, I just jumped from 1 to 6. I jumped every 5. It very slowly, very, very slowly, like the first 16 eclipses are within 2 degrees of the horizon. And up even the first 21. So actually I'm wrong about what I just said. This one here is the 21st eclipse. Let's correct what I said. It's still near the horizon. So the first 22 eclipses are very within a few degrees of the horizon. It means if you travel to that place to see those eclipses, they will be near the horizon. The other thing is that the first eclipses are partial. They're not total eclipses. The last ones are partial. The total happen in the middle. And these are called annular. Annular means that the moon visually is smaller than the sun and there's a ring of the sun around the moon when the eclipse occurs. Every eclipse in Saros Cycle 147 is annular. Every single one. They all have a ring of the sun around the moon. So if you go to the place of maximum eclipse, you're going to see the total eclipse with that little ring of the sun around the moon. And that's because what we learned in the first series in this video is that the distance of the moon from the Earth is similar, not identical, but similar, and the moon is far away. So this is also fascinating. In Saros Cycle 147, the moon is always far away from the Earth. In the first video in this series, I quoted from the NASA website, this great astronomer, Fred Espenak, is the one who wrote that article. He's an expert in eclipses. And he says that the geometry of the eclipses in the Saros cycle is very similar. And one of the ways in which they're similar is the distance of the moon from the Earth is similar. It's far away. When the moon is far away, it's smaller, and you have an annular eclipse. Annular means ring. The ring of the sun is around the moon. So, now this is interesting. I did not expect this. When you go from the 22nd eclipse in this Saros cycle to the 23rd, it jumps way up in the sky. So if you traveled, if you were alive at the time that this eclipse occurs, and you traveled to see it, it would be 24 degrees above the horizon. That's what altitude means. How far from the horizon? It's going to be much easier to see. I mean, you're going to see it much more. It's up 24 degrees as opposed to these right on the horizon. And the first annular eclipse is still near the horizon, and then as they start getting the first two, and then they start being more visible, they get higher and higher in the sky. And then by the time we get to the middle range, the 34th to the 41st, this is the middle range of this series of eclipses in this Saros cycle. It's almost directly overhead. And these are the most perfect annular eclipses in the entire cycle. So when that eclipse occurs in the middle of the Saros cycle, it's the most perfect. The moon is going to come the most perfectly right to the center of the sun. And if you go to the place of the maximum eclipse, it will be nearly over your head. So all of these are within, well, I went out to 84. They're all within 6 degrees of being over your head. So almost directly overhead, and at its most perfect, within 2 degrees. 35th and 36th one. Anyway, it's almost directly overhead. So it's interesting. The first eclipses happen on the horizon. The middle ones happen over your head. And the middle ones are the most perfect. Perfect meaning the moon moves smack right in front of the sun. And we can talk about why this is true, what's actually happening. But this is enough, just to understand the facts, and then you could think about how the Earth is spinning on its axis and what it means. It makes sense. It means the sun, moon, and Earth are aligned. It's like they're dead on. And anyway, and when it's perfect, it's going to be like a direct line. Anyway, that's what happens. It'll be at the zenith, and then you see it drops down. And notice this sudden drop from the 56th eclipse in the Saros cycle to the 60th, 4 later, it's gone from 54 north to 23 north, and then 23 north to 7 north in just one eclipse. Just 18 years, 11 days, and 8 months later, the next one jumps. So that it's steady, much more steady and direct and simple than when we look at where the eclipse is in relationship to the geographic latitude on the Earth. The altitude, much more steady, but it changes speeds. Sits near the horizon for a long time, and then moves up, and they occur at the zenith when they're exact, and then it moves back down. So that's just what happens. It's just nice to know what's happening. So when you're looking at an eclipse that's really like a perfect eclipse where the moon moves right center, right in front of the sun, the maximum, when it's maximally visible, it's also at the zenith. Interesting, really dramatic. So here's an interesting thing. Not all total eclipses are equal. Total eclipse just means that the moon moved in front of the sun, and either it covered the entire sun, total, or there's a ring. But it's at this 21st eclipse, for example, and the 22nd eclipse, there is a ring around the moon, but the ring is not perfectly the same size. It's like a ring where part of it's slightly thinner. Maybe not so obvious to the human eye, but the moon is moved right in front of the sun with a ring around it, but the ring of light of the sun is not a perfect ring with the same thickness. As it gets into the middle, that ring becomes more perfect. The moon is moved more perfectly into the center. And we can show that, by the way, by looking at the latitude and longitude, or look at the latitude of the moon. You can also look at the difference in altitude, and they're more exactly the same in the middle, in these middle eclipses. They're the most perfect eclipses. Perfect meaning the moon has got right, the center of the moon has moved the closest to the center of the sun. Okay, so these are just facts about what's happening. And this bold blue I mentioned here are sudden changes in altitude. From the 22nd to the 23rd to the 24th, eclipses in the Saros cycle, dramatic change going from 3 north to 34 north. Same thing at around 61 north, dramatic change from 23 north down to 7 north, down to 1 south, very rapid change in the altitude at which it's visible. What does it mean in terms of interpretation? I think for astrologers, I think it just means that not all total eclipses and not all annular eclipses are equally total or equally annular. The more exact ones are going to occur right over your head, and the altitude of the planets will be more similar, and the latitude of the moon at those locations will be closer to a perfect 0 north, 0, 0, 0, just like the sun. Okay. So, just to review here, the first eclipses and last eclipses in a Saros cycle are partial. The eclipses near the middle of the Saros cycle are annular or total. Now, this is interesting. For some Saros cycles, all are annular, as in this one. In Saros cycle 147, there are no total eclipses. They are annular. Annular is kind of the same as total, except it means the moon is smaller than the sun, and there's a ring of the sun around the moon. So it's not total in the sense that this sun is not completely covered by the moon. There's that ring around it. And for some Saros cycles, all are annular. For some, all are total. And for some, it will change. Here's an example. Let's go to this website. Oh, I closed my browser. I'll show you how to find it. That's okay. Let me open my browser and let's look at Saros Cycle 157. So I'm going to go in here and in Google, let's search for Saros Cycle 157. And you will see a Wikipedia article. Here it is, Wikipedia. I want to thank Alexander Zaragich for this. He told me about this, how you could see this nicely in Wikipedia. And it's true, it's beautiful. If you look at the Wikipedia article, they will show you every eclipse in the cycle. So for Saros Cycle 157 begins in 2058, hasn't even started yet. And notice they're all partial until the 7th eclipse is annular. And they remain annular, and then they change to hybrid. Hybrid means it transitions from one to the other. It means the sun and moon are almost precisely the exact size. I mean, they're just like so close. And then total, and it remains total. So in a Saros cycle, you can characterize Saros cycles. Are they annular? Saros cycles means the moon is far away in all of them. Are they both annular and total, which means the moon is at like an average distance from the Earth? So some of them are where the moon is smaller than the Earth, and then it changes to the moon being big. Sorry, some of them the moon is smaller than the sun, visually smaller, and in others the moon is visually bigger. So it's going to change from annular to total or total to annular, or are they all total? So for astrologers who want to interpret Saros cycles, we have all these different types. Like the type that I was born in, they're all annular. I was born 3 days after the eclipse on April 28th, 1949. Let's go back to it. Oh, whoops. Well, it's, we'll get to it. I know what I want to do. I want to show it to you in the program. Okay, sorry about this jumping around. Here's what I want to do. If I pull this up, solar eclipse, April 20th, just as an example, you can pull up the solar eclipse before you were born, which, by the way, you can go to there's several ways to do it. There's several ways to see it. You can put a table in here. Maybe I should show you that. There's several ways you can find your prenatal eclipse and prenatal lunations in the Sirius software. One is you can add a table to show it in the wheel. I'll show you that in a second. But what I want to show you now is that this is the eclipse. It's also the new moon. The new moon before I was born is Saros Cycle 147, number 19. It happens to be a partial eclipse. So later on in this Saros cycle, they will be more exact, and they will all be annular eclipses. They will all be annular eclipses. And we can pull the article up in Wikipedia to show that. if we want to. But what I was going to show you, this wasn't in my plan, but let me show it to you, is if I right click, go to Customize, go to Page Designer, and I add a table, this Technical Lunations table. Let me drag it over here, and then I right click on it. This is the Page Designer feature, and I add in the nearest lunations and nearest eclipses. How cool is that? You just add them in there. That actually kind of already fits. And what I'll do, I'll say done. I will drag this a little to the left. Now I'll right click on the wheel and I will make it smaller. Isn't this cool? You can just control everything very fast. Now I'll click done. Okay. 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 There it is. What did that take? Like 2 minutes? In 2 minutes now I have my nearest lunations, my nearest eclipses. And there it is. Sun, new moon conjunction symbol. That's a new moon. At 7 Taurus 42 on April 28th, 8:02. So there they are. There's the nearest eclipses right there. And here is the lunations before I was born with the new moon, 7 Taurus 42. So this is telling me that this new moon, just before I was born, is a partial eclipse right there. Okay, so that information is, can be right there on your chart wheel if you want it. Very, very nice. So if I go to my chart now, I would see this. I'm looking at an eclipse chart, but more interesting is if you look at the birth chart of someone. Here's my birth chart. Now I've got this table. So I was born on May 1st, 1949, and now I see that same information. Partial eclipse. This line is before birth. These are after birth. There they are. So, okay. Very, very cool. Now it's not telling me, it's just telling me it's a partial eclipse. I can pull up that eclipse chart and I'll see what Saros cycle it is and what number it is in the Saros cycle. Okay, let's get back to what we're talking about. We're talking about what is actually happening in the eclipses within a Saros cycle. They occur, each succeeding one occurs 11 days and 8 hours later. The sun and moon move about 11 degrees. The north node moves about 11 degrees. And the distance of the moon from the earth is about the same. And if the moon is very far away, it'll stay far away throughout the entire cycle, which is what happens with some of these eclipses. In fact, let me show you. Let's go back and let's see if I put in here 147, or you could go to the Google search and search for Saros Cycle 147, and you see that all of them are, let me stretch this out as much as we can within the area I'm capturing on my screen. And there it is, Annular. So this is the Saros Cycle 147, begins on October 12th, 1624. Now, they do a weird thing. They use old style calendar or something instead of new style. I don't know. But don't worry about that. But here, it shows you the first 21 eclipses are partial, then they're annular, and all of them are annular. So I was born 3 days after a Saros cycle where all of the eclipses are annular. All of the eclipses, the moon is far away. Maybe that means something astrologically. Maybe it means the moon is like more collective and less personal. You could speculate about it and look at charts to see if you can make sense of it. But there are different kinds of Saros cycles. There are the distant moon Saros cycles and the close moon Saros cycles. The close moon Saros cycles, all of the eclipses will be total. The far away, they're all annular. I was born on a distant Saros cycle, 3 days after a partial eclipse that's part of a distant or annular eclipse series. It's very interesting. Just how the Saros cycle is organized and what happens, it's fascinating. And as astrologers, we think that this could all be relevant to our lives, but even for just astronomers who wouldn't think that, it's still interesting. Now, we're at 35 minutes, going on 36 minutes. We'll stop here, and then we'll start the third in this series on the Saros cycle. And this third one, I think, is, for me personally, the most interesting of all. This is really fascinating. We're going to show vibrational beats in the Saros cycle. And as you can see, we're talking about here. We're going to pick up with this with the third video in the series. For me personally, this is even the most interesting all, and this is totally new information, and quite sure nobody else has gotten into this, or if they have, I certainly haven't seen it. So this will be interesting. Okay, my friends, let's stop here, and in the third video in the series, we're going to talk about the beats, the vibrations that run through the Saros cycle. Okay, see you in the next video in this series. Okay, bye for now. God bless. Namaste.